Good afternoon, everyone. This is Ali Mastardo, Executive Director of AMAP. I would like to thank you for joining us today for our webinar, The Use of Sustainable Concepts in the World of Modified Asphalt. We do have you all on mute for the webinar. If you have any questions, please use the question function on your panel. They will be answered at the end of the webinar. Lastly, this webinar is being recorded and will be sent via email to all registered attendees. Before we begin, I would like to introduce you to today's presenter, Dr. Andrew Braham. Dr. Braham is currently an associate professor in the Civil Engineering Department at the University of Arkansas, where his teaching and research focus on asphalt emulsions, pavement maintenance and rehabilitation, and sustainability. Dr. Braham is also an avid Wisconsin fan and even loves the Packers. Please welcome Dr. Braham.
Thank you, Ali. I appreciate it. And for all of those who know me, you do know I'm an avid Packers fan and Brewers fan, and I am a complete bandwagoner for the Bucks when they're doing well. But thank you for that very nice introduction. As Ali mentioned, today I'm going to talk about the use of sustainability concepts in the world of modified asphalt. A little bit of a presentation overview. I'm going to start kind of broadly, and if you've seen some of my presentations on sustainability, I hope that this reinforces some of the concepts that you may have heard from me before. But I do want to define my definition of sustainability, and those fall under the 3 pillars. Then we're going to pivot over to some very specific tools that are used when trying to quantify sustainability, and that includes Lcca, which is life cycle cost analysis, Lcas, which are life cycle assessments, and Epds, which are environmental product declarations. We'll then start talking about where are agencies in the world of Lcas, Lccas, and Epds. And then we're going to finish off with giving some specific examples of where Lccas, Lcas, and AMAP kind of overlap in interest areas. So to start with, what is sustainability? I am fully cognizant that this is flirted with a buzzword status. Resiliency has kind of replaced it. Climate change has kind of replacement, but I am familiar with that. That being said, though, I do think it's a very important term, and it's worth thinking about and reflecting on whenever we move forward in our research and project areas. And when I think of sustainability, I really think of it having its roots in the United Nations. And there are several documents, they're all available online free of charge, that have started talking about these concepts of sustainability and how they've developed over the years. For example, in 1980, the UN put out the World Conservation Strategy, and this document really focused on just the environment. I think that one that many people are familiar with, or at least are familiar with the name, is the Bruntland Commission report, which was put out in 1987. And a key quote from this report is, meets the needs of the present without compromising the ability of future generations to meet their own needs. So this is taking a little bit of a step back and not just necessarily focusing on just the environment, but talking about kind of everything from a more holistic standpoint. And then in 2002, during the World Summit on Sustainable Development, this is when the UN introduced this concept of the 3 pillars. And it's my understanding that this is where this concept of the 3 pillars first came about. And that is defining sustainability in terms of economic, environmental, and social considerations. And so that's what we're going to talk about over the next couple of slides, or what does it mean when we say economic, environmental, and social considerations. Well, let's start with the first pillar, which is the economic pillar. And there are 4 common tools that can be used. By far the most common is life cycle cost analysis, or LCCA. And the nice thing about the life cycle cost analysis is it incorporates both initial and discounted future costs. So instead of just looking at a project's initial costs, it looks at a project over the lifespan of the anticipated length of the project itself. Another economic tool is a present, future, and annual worth concepts. And this is where you can go from present dollars to future dollars, translate that to annual worth dollars. This really provides a lot of flexibility of the concept of time when looking at cost comparisons, because obviously over time, costs change and it's helpful to have them all in one certain form. Now, you may have heard me give a presentation on sustainability, and you also may have heard me give a presentation on roadresource.org, which is one of my favorite websites, along with espn.com and airliners.net. But roadresource.org is a phenomenal website, and it includes tools that actually leverage life cycle cost analysis and the concept of present, future, and annual worth. So if you haven't been to roadresource.org, I'm sure a lot of you have, but I definitely recommend you check it out. It is a phenomenal tool. A couple other tools that I do want to reference, we won't spend much time on them, but the rate of return, this is an economic concept that you'll see, especially when you're issuing bonds for infrastructure projects. Obviously, infrastructure projects cost a lot of money, sometimes in the tens of millions of dollars. And so you may need to issue bonds in order to raise the money to complete those projects. And you'll see the rate of return mentioned quite often in those calculations. And then finally, the fourth tool is a benefit cost ratio. This is a very popular service analysis technique. And the reason is you get a single number. And if it's greater than one, it's good. If it's less than one, it's bad. So it's a very, very easy way to try and compare different options or to see if the option is even worth pursuing. Now, as I mentioned, the life cycle cost analysis, or LCCA, is by far the most common tool in the pavement industry, and I will talk a little bit more about this later. In the meantime, let's pivot over to the second pillar, which is the environmental pillar. And again, I found 4 common tools that can be used for the environmental pillar. The first is the LCA, the life cycle assessment. And this has a lot of the same flavors as a life cycle cost analysis, but instead of looking at dollars, you're looking at emissions, energy use, wastes, and those type of environmentally related concepts. And I could spend literally hours talking about a life cycle assessment. And if any of you know Dr. John Harvey at UC Davis, he could probably spend days talking about this. This is a core area of his research, but I'm just going to try and summarize it real quickly here. The point of an LCA is to compile and quantify inputs of 4 stages. And these 4 stages are your product and materials, the construction stage, the use stage, and the end of life stage. And so what we're trying to do is we're trying to figure out what sort of energy goes into this, what sort of fuel use goes into these stages, and then what kind of emissions, what kind of wastes come out of them. And you do that in the 4 stages: the product materials, the construction, the use, and the end of life. And when you compile and quantify these inputs and outputs, you can also hear these referred to as environmental flows. So what are some of these inputs and outputs? Inputs to a life cycle analysis, a life cycle assessment is extraction, transportation, manufacturing, and maintenance. And then outputs are fuel and or electricity use, any sort of waste that are generated. And you'll often see these divided into solid waste, liquid waste, or hazardous waste, and any sort of emissions as well. And what you do is then you take these environmental flows, which are the inputs and the outputs, and those alone sometimes aren't terribly helpful. They give you some numbers, you may be able to compare them, but we want to translate those flows to environment and human impacts. So it's one thing to quantify the fuel use, the waste, the emissions, but it's another thing then to talk about how does that actually impact the environment? How does that actually impact humans? And so some examples are depletion of resources, human health, depletion of the ecosystem, these type of things. So there's a lot of details that go on along here in the background, but this is kind of a nice broad overview of a life cycle assessment. Now, there are a couple other tools that are out there, and you can Google all these terms or use whichever search engine you'd like in order to find out more of them. But the first is the ecological footprint. And basically what we do here is we look at consumptions, and then we also look at what sort of land use you need to use, and you make a matrix. So this is how much we'll consume. These are the land resources that we'll need to use. And you talk about concepts like food, energy, air, water, fiber, clothing, shelter, those type of things. So it's just a different way of looking at how much we're using and how many resources we actually have available to use. So it's a pretty interesting system. Planet Boundary is another pretty popular environmental tool, And this is where the Earth was divided into different subsystems. Some examples are climate change, biodiversity loss, biogeochemical flows, those type of things. And basically they have tried to rate it, saying what is an acceptable level of these, and are we below or are we over them? If we are over them, how far over them are we? So it's just trying to quantify those type of concepts. Now, there is a EPDs is the fourth tool that can be used in the environmental pillar, and this is actually directly related to the Lcca, as we'll see in a minute. But environmental product declarations are very important, and I know that if you work for a company, this is probably something that is very much on your radar. Now, when I think of an environmental product declaration, I think of this as a safety data sheet. Those used to be material safety data sheets, but you have to send those with any sort of material that you ship in the mail, whether it be a chemical or asphalt binder, a polymer, those type of things. But it's kind of for the environment instead of for human safety. So what kind of impact do these materials have on the environment? Now, a key part of EPDs that you should always be very in tune with is what is the EPD capturing in the product's life cycle? And so some common examples are cradle to gate, cradle to grave, and cradle to cradle. So cradle is just what it sounds like. It's taking raw materials out of the earth. The gate is when it leaves a production facility. The grave is the end of life of that product. But then cradle to cradle is how can we then use the material left at the end of life and put it into new products? So in the world of asphalt pavements, reclaimed asphalt pavement or RAP is a very good example of looking at the cradle to cradle. After the pavement has reached the end of its life, we still try and use that material in order to get some value out of it. And like the LCCA, we will talk more about the EPDs as we move forward. So we've covered the first pillar, which is the economic pillar. We've covered the second pillar, which is the environmental pillar. And the third pillar is the social pillar. And again, I'm going to turn back to the UN. There's a bunch of different ways that we can look at this, but we're going to start with the UN and kind of continuing on with the UN's progress over the years. And before I start diving into the UN and some other tools that are out there, I do fully acknowledge that the social pillar is more difficult to quantify. It's a little harder to assign numerical values. It's obviously very straightforward to assign a dollar value or amount of carbon dioxide emitted. So the environmental and the economic pillar are relatively straightforward, but the social pillar is a little more qualified centered. And so in 2007, the UN put out the Commission on Sustainable Development themes. And you can see here it's revolving a lot around both social and environmental concepts. So poverty, governance, health and education, demographics, those kind of lean toward the social side. Natural hazards, atmosphere, land, ocean, water, those type of things, those fall a little more on the social side. In 2012, the UN put out the report on the UN Conference on Sustainable Development. And you can see here, this is kind of pivoting a little more to developing countries and also the people in those developing countries. So they talk about themes like empowerment, removing opportunity barriers, enhancing productive capacity for the poor and vulnerable, focusing on children. So you can see it really moving in a social direction here. And then in 2015, they continue this direction with transforming our world. They talk about poverty, health, education, and consumption. And they go on moving, in addition to children, focusing on women and females, inequality, and institutions. So these are just some examples from the United Nations. Now, there are other tools out there as well. So if you survey some transportation technical journals, this is what I do in my spare time when I'm not watching the Packers. I read technical journals, and there's a whole bunch of different things out there about the social pillar. So for example, when we're thinking about transportation, it's relatively easy to quantify trip length. If you commuted into work today, how long did it take you to drive there? That's the trip length. Job accessibility, how easy is it to get to your job? Especially if you don't have a car to use on a daily basis, what sort of mass transit or alternative options are there? What sort of safety concepts are there, either on a job site or when you are moving from point A to point B? Things like this you can start to quantify, and there's a whole bunch of journals out there that are available that dig into these. Another social tool is called the Oxfam Donut. And what this is it is a blend of the planet boundary and the UN metrics. So it kind of took the environmental pillar tool, the planet boundary, it combined a bunch of metrics from the UN, and it made a donut. And the planet boundaries on the inside, the UN metrics are on the outside, and you kind of are looking at both those concepts together. Another tool that's pretty popular and has been used is called the Human Development Index. And this is trying to look at human well-being beyond economic measures. You've probably heard like per capita income for countries, but trying to move on just beyond that $1 amount, trying to classify people. So looking more at things like your longevity of life and how healthy you are, the amount of knowledge you can gain, your standard of living, those type of things, which kind of go beyond just a single dollar amount. And then finally, the social impact assessment is the last tool I'll discuss. And this is kind of a safety data sheet, but for the social pillar. And so they talk about concepts such as lifestyle, cultural, community, quality of life, and health, these type of concepts, and they try and capture where a social perspective is on these different types within the social impact assessment. So I covered a lot of ground. When you receive the recording of this, I encourage you to kind of go back and you can search any of these phrases, and there's quite a bit of material available online for free. And you can dig into any of these either economic, environmental, or social tools that you may have interest in. However, I think from our perspective and what we talked about with AMAP on developing this webinar is trying to understand, well, what are the agencies doing, and then how does AMAP overlap with what the agencies are doing? Well, if you look at section 23 of federal aid highways, I do not recommend looking at this if you are trying to stay awake for a long period of time, but this is literally what's written into the law. And there is language about life cycle cost analysis in the federal aid highways documents. Now, I cut and pasted some of these. I don't promote plagiarism in any form, but I wanted to capture the exact wording that's used because it's actually very interesting when you start digging into this. So the federal government says about life cycle cost analysis that we shall develop recommendations for the states to conduct life cycle cost analysis. We shall not require a state to conduct a life cycle cost analysis, but then they go on to say they want to establish a program to require states to conduct a life cycle cost analysis on projects that are more than $25 million. So what does all this say? It says that LCCAs aren't required. And to me, this is kind of a disappointment because constantly just looking at the initial price neglects what are we going to do in the future. And one of the things I love about my job is it's so easy to convince people that we need to do more and we need to do better fixing our roads. And I personally think that one big thing that we could be doing is moving beyond just the initial construction and looking at the life of a road and trying to develop cost strategies associated with that. So that's what the federal government says about life cycle cost analysis. Now, for environmental product declarations, there's nothing in the federal aid highway documents about EPDs or life cycle assessments that I could find. But when you kind of look at what individual states are doing, there are actually many agencies moving forward to incorporating and or requiring EPDs. Now, I do want to make clear that you can't just generate an EPD. I can't sit here and write an EPD and say, we're good, we don't need to do anything else. In order to deliver a publicly accepted EPD, you need to start with an LCA or a life cycle assessment. You then go through a process and the end product can be an EPD. So it's actually quite an involved process. Now we're seeing who is starting to require EPDs. The state of California is actually requiring EPDs for some construction materials, such as steel and some other that I should have reviewed before this webinar, but they are requiring some EPDs for construction materials. Also, you can see here a whole list of other agencies and organizations who are also moving toward potentially requiring EPDs. So it's my humble opinion that EPDs are coming, or whether we like it or not, And it's in our best interest to try and get out ahead of them to understand what we need to do in order to work in that space. So this is what agencies are requiring when it comes to sustainability, or what they're talking about. Now, what I want to do is I want to hone in on life cycle cost analysis. I want to hone in on life cycle assessments, or LCAs, and I want to hone in on EPDs, because I think these are the three things that moving forward within the next 5 to 10 years, I think there'll be a lot of activity in these three areas. So in order to do that, let's kind of look at what do LCCAs and LCAs look at, and how can we represent them visually. So to start out with, I talked about different stage. Let's look at those stages in a little more detail. For example, we have the product stage, which is often labeled A1 through A3. And you can see here, this involves raw material supply, the transportation of that raw material to a factory or manufacturing facility, and then the actual manufacturing of the products. Then you have your construction stage, and this is the transportation of your manufactured product to a job site, and then you actually construct it or install it. And then you have your use stage. So once it's out there and installed, once that road is paved, you use it, you need to maintain it, you need to repair it, you may need to replace it at some point, you may need to refurbish it. But you can see here the product and the construction stage are all represented by A1 through A5, and then the use stage is represented by a B. Then we have the end of life stage, which is the C phase, and this is your deconstruction or demolition, your transportation of that waste, your waste processing, your disposal of the waste. So this is all what happens at the end of the life stage, and this is C. And then we also have tacked on here this D, which is the reuse, recovering, or your recycling potential. So you can dispose the waste, you can either place it in a landfill, or you can divert that waste and reuse it or recycle it in a different stream. And I mentioned before, RAP, reclaimed asphalt pavement, is a very good example of that. Now, I also mentioned the terms cradle to gate, cradle to grave, and cradle to cradle. If you look at the A stage, the product and the construction, the cradle to gate is just the product stage. So it's A1 through A3, and then it leaves the gate of the manufacturing facility. So that's cradle to gate. Cradle to grave is A, B, and C. And then cradle to cradle is A, B, C, and D. So you can look at those three different terms over these stages that are shown here. So how does this relate to LCCAs and LCAs? Well, life cycle cost analysis, you look at both agency and user costs at each one of these stages. So how much does the agency spend to get the material, construct the material, use this material, and then dispose of the material? And what are user costs associated with that? And this really comes into play on the use stage, the end of life stage, because that's when users are most frequently interacting with the material. And then we have the LCAs. And the LCAs, what they do is they translate any outputs of these stages. So during production, you obviously use either fuel or electricity. During production and construction, you generate wastes. You can have solid waste, liquid waste, hazardous waste. During all these stages, there are emissions, and these can be both the contractors, the manufacturers, it can be the users' emissions. And what we need to do is we need to take all of those outputs and translate them to actual impacts. And those are, how many resources do we deplete? What effect does this have on human health? All of these type of things. And as I mentioned before, an LCA, if you perform an LCA, you can then do a PCR, and that leads to an EPD. So let's dig a little deeper into LCCAs and EPDs specifically. So there are 8 steps to an LCCA. First of all, you need to develop your maintenance and rehabilitation strategy for some sort of analysis period. So if you design a pavement for 20, 30 years, when are you going to maintain it? When are you going to rehabilitate it? What sort of timing are we going to have for each of these strategies? And you want to try and estimate both the agency costs for all of this and the user costs. So once you have developed the timing and the actual strategies that you're going to use over the life of the pavement, you then try and estimate the cost to the agency for the construction and any sort of maintenance and rehabilitation. It's very tricky, but you also want to try and do this all for users as well. Then you show some of these things graphically using what's called an expenditure stream, but then you take all of these costs, so not only the initial cost, which is the construction cost, but any sort of maintenance and rehabilitation costs and the end of life costs, and you bring those all back to present costs. And that's called the net present value. And that'll give you $1 amount that not only reflects the actual today's cost of constructing it, but then also future anticipated costs with the maintenance and rehabilitation. You then analyze your results, and I could go on a little rabbit trail here talking about deterministic versus probabilistic. In simple terms, deterministic assumes that there's one solution. Probabilistic recognizes that there's variability in pretty much any assumption we make. Therefore, you get a probability distribution of your net present value. So you have some sort of mean value in the middle, which is generally a deterministic value, but then there's sort of probability distribution associated with that. So you can try and estimate where it'll be within a range. But then you can evaluate different strategies. So hopefully you looked at a couple different maintenance and rehabilitation strategy. Maybe you looked at different building materials, but you evaluate them, you compare them, and if necessary, you go back to step one and you start the process over. And this can be shown visually. So let's take a look at my favorite example, which is comparing a chip seal to a 2-inch overlay. So here on the y-axis, we have the pavement condition, and a very common pavement condition index is A, B, C, and D. So A is a perfect road, and then as you get down to C and D, it gets worse and worse. And here I just defined D as the terminal serviceability of the road. That's arbitrary. There's no scale on here, but just for demonstration purposes. And then you can see on the x-axis, we have our pavement life, which here goes from 0 to 50, but this pavement life, you can analyze it however you would like to. So we have our two different alternatives. We have a chip seal treatment or we have a 2-inch overlay treatment. And so we need to assume when we're going to place this chip seal and when we're going to place the 2-inch overlay. So here we assume that we're going to wait till your PCI gets to a PCI level C, and then we'll apply a chip seal. When it gets down to D, we're going to do a 2-inch overlay. And you can see here that the chip seals are more frequent, so they happen more often, but they're less expensive. And here I just kind of defined the chip seals as being placed at 6, 12, and 18 years. So in 6-year increments, you just go on. And the 2-inch overlay is less frequent, but it is more expensive. And I define it as 11, 22 years, and so on. So if you go to roadresource.org, you can actually do this experiment, and you can go into one of their tools, life cycle cost calculator, and you can do a chip seal at year 6, at year 12, at year 18 for any length of network you want, and you can compare that directly to a 2-inch overlay. And you need to put a price in, you need to put in the life expectancy of those treatments, but you can play around with those numbers based on your local conditions, and you can get a life cycle cost analysis. This is a very brief overview of a life cycle cost analysis. This is a shameless plug of a webinar series that I do, but if you're interested in learning more about life cycle cost analysis, you can Google Lcca Pavinar, P-A-V-I-N-A-R, and I think it's about a 45 minute webinar just about life cycle cost analysis. So that's a nice resource if you want to learn a little more about this. Now let's take a look at EPDs. This is the second area that we're going to focus on. And as I mentioned before, EPDs are the end of a 3-step process. In order to generate an acceptable EPD, you first need to do a life cycle assessment. And as I mentioned, life cycle assessments include the inputs and outputs of production, construction, use of end of life. And this includes any sort of transportation of materials or wastes, anything that you have at each of those stages. And this includes all of the inputs and outputs are emissions, waste, and energy use, and we translate those to human and environmental impacts. So you first have to do a life cycle assessment in order to get an EPD. Next, you need to execute what's called a product category rule, or a PCR. And this is a set of rules, requirements, and guidelines for developing EPDs. And these are very important because, as I mentioned, you just can't generate an EPD out of thin air. You need to first perform a life cycle assessment, and then you need to follow the PCR, and this includes all these type of things. So definitions, descriptions, goals, stages, environmental flows, impact, all of these type of things. And this ensures that you are building a solid foundation in order to generate the EPD. So if you perform the proper life cycle assessment, if you perform the product category rule, you have confidence that you will generate an EPD that will be accepted. And there's a couple of very important steps here for PCRs. You can see these are only good for 5 years. So every 5 years, you need to refresh your PCR to make sure it's current and accurate. And then also you'll notice that a third-party review is required for a PCR. So this ensures that not just anyone generates a PCR, but there's actually a community involvement in generating this PCR and community acceptance of the PCR. And after the LCA and the PCR is developed, you can produce an EPD. And as I mentioned, I see these as a safety data sheet for the environment. Now I'm going to go over an example of an EPD, and this is publicly available from NAPA, the National Asphalt Pavement Association. So if you go to NAPA's website, they have done an extremely large amount of work on LCAs, PCRs, and EPDs. And one of the requirements of developing these is they all need to be publicly available. Well, the LCA and the PCR needs to be publicly available. So if you go to NAPA's website, they have their LCA on there, they have their PCR in there, and they also have a lot of the background documents that generated those two tools. Now, NAPA also has a tool where you can, if you're a member company, you can generate a site-specific EPD. And what this means is if you are producing hot mix asphalt or warm mix asphalt at a plant, you may need to generate a specific EPD for that plant for the asphalt concrete mix that you are producing. And NAPA members, they have a choice. They can post their EPDs online so anyone can look at them, or they can generate an EPD and keep it to themselves. So if you dig around on NAPA's website, there are a bunch of publicly available examples of EPDs. And I encourage you to take a look at those if you have not already. Now, EPDs are 10, 12, 15 pages, something like that. There's a lot of good information in there. But in my mind, the meat, the heart of the EPD is this summary table. And you can see the summary table looks at specific parameters. And the parameters that this EPD lists are global warming air, ozone depletion, acidification, eutrophication, smog air, and abiotic depletion of fossil resources. So these are the 4 parameters that they are measuring the impact to the environment from making asphalt mixtures. So we got our parameters, you can see the units there. And then we have our 3 different stages. So you'll note that this is a cradle to gate EPD because we're looking at A1, which is materials, we're looking at A2, which is transport, and we're looking at A3, which is the production itself. So if you guys have ever been to a asphalt plant, the aggregate comes in. So it's measuring all of the emissions and sorts of things associated with that, wastes of getting the aggregate out of the ground and bringing it to the plant. The transportation associated with bringing that raw material to the plant, also the asphalt binder and any additives that you may be adding, and then the production of the mix itself. So this is what we're looking at with NAPA. Now, in my mind, the numbers themselves standing alone are relatively meaningless. I can't sit here and tell you what 9.89 times 10 to the negative 11th kilograms of CFC11 equivalent will do for your ozone depletion air. That was A2 ozone depletion air. Like, I really have no frame of reference for that, but you can compare this table to other tables of other materials to see what sort of differences and similarities there are. And the one that I chose here, it happened to be for 1 short ton of asphalt mixture. It's a dense graded 3/4 inch nominal maximum aggregate size, 0% wrap hot mix. So for those of you familiar with asphalt mixtures, you'll immediately think, well, what happens when you add wrap? And you can go to NAPA's website and you can look at EPDs that have wrap in them, and you can compare those EPDs to one another. You may ask, what if you use warm mix instead of hot mix? Well, you can go to Napa's website and you can look at an EPD that used hot mix, you can look at an EPD that used warm mix, and you can compare those next to each other. So there's lots of good opportunities, and Napa's done a phenomenal job of putting those all on their website free of charge, and you can take a look at them and dig into them to your heart's content. So that's my background. We talked about sustainability. We talked about the 3 pillars. I honed in a little bit about on what agencies are doing, at least my interpretation of what agencies are doing when it comes to sustainability in the 3 pillars. And I identified LCCAs, LCAs, and EPDs as kind of their focus areas. So this is an AMAP webinar. So what does this have to do with AMAP? Well, to tell you the truth, when I was putting this presentation together, I did not know how AMAP defined a modifier. And in order to talk about AMAP and their modifiers, I just went to their website and they defined what a modifier is. And their definition, AMAP's definition of a modifier is something that is added to asphalt to improve the performance grade through chemical or physical alterations. And in this definition, the extended definition, they talked about some general categories: polymers, acid, light oils, GTR, which is ground tire rubber, and recycled products. But then if you dig a little deeper into AMAP's website, they actually have a huge laundry list of all the different materials they consider modifiers. And these are those materials. Don't worry, I'm not going to read this. I don't think I could pronounce everything correctly, but you can see there is a whole slew of different type of modifiers out there. And I think it's of high interest to understand, how do these modifiers impact the 3 pillars? How do these modifiers impact LCCA and LCAs and EPDs? And what are the pros and cons of potentially using these? So what I did is I did a literature review search. I tried to look for resources that are available online for free. There's a ton of material out here on all of these topics, but I tried to find reports that you could download. I've only got an hour for this presentation. For those of you who know me, I could go much, much longer than that. But another thing, for those of you who've watched my presentations, I really do like trying to provide additional resources because there's just a lot of good information out there. So let's look at a couple of examples. Let's start out with chrome rubber or ground tire rubber. So when you look at chrome rubber or GTR and you look at the initial cost, it's generally more expensive than neat asphalt binder. It's generally less expensive than polymer modified asphalt binder. So right away, if you just look at the initial cost, you don't look at the life of the product, you may not be getting all of the information. Because if you start to look at the life of the product, the research project by Butler and Rath here that was produced in 2021, and I'll provide a title in the upcoming slides, they found that you can make a thin overlay with rubber, and that can be 43% cheaper over the life of the pavement and have a 10% better lifespan versus unmodified. So yes, it may cost a little more initially, but you can see you're getting long-term savings and life extension off of that. And they also found that if you try and get the same performance, you can actually get a 50% reduction in thickness. So that will actually reduce the initial cost because of the advanced performance. So there's a couple things here that I want to unpack and focus on. You can see that, one, looking at the initial cost can sometimes shortchange you, but two, there are different ways then that you can look at the life of the product. You can either change the costs associated with maintaining it. You can look at the life extension that you could potentially get, or you could look at changing the structural design in order to get the same lifespan. So there's a couple different levers that you can pull in order to examine 2 products next to each other. And they found that looking at a life cycle cost analysis, their final conclusions were you could save anywhere from 40% savings using rubber. And this goes back to those levers. Depending on which lever you pull and how far you pull it, you have different savings. And when they looked at laboratory data, they did a lab side study here. They actually found that due to performance characteristics, you can have up to 400% savings. So there's a lot of information here to unpack and a lot of slightly different ways to look at it. And when you look at overall takeaways from this research project, project. There's less tire wear when you use GTR. You have a reduction in rolling resistance, which means you have less fuel consumption. That goes back to agency versus user costs. They also looked at the life cycle assessment. Now, I mentioned cradle to gate, cradle to cradle, cradle to grave, those three different ways of looking at the life cycle. The LCA that they performed only looked at the production process, so extracting the materials from the ground, trucking them to the job or to the production facility, then manufacturing it, and that's where it stopped. But they did believe that this is where rubber had the higher impact. And they found that when you include include the use stage, they anticipated that it will have even an additional lower impact than what they saw at the production process. Now, they also made an interesting statement that a lot of LCA studies are what are called attributional, which is just comparing two or more products, and not consequential. And in my mind, this is actually an area that we need to do better in, because there are quite a few LCAs out there that compare product A to B, but we need to do a better job of laying a solid foundation so we can just talk about one product and this is what it does, not necessarily just saying one product versus another product. So I found that to be an interesting takeaway. Now, this is one of the things that I encourage you if you want to learn a little more about this. Bill Butler, he was actually my advisor at the University of Illinois. He always does fantastic work. He's now at the University of Missouri. But if you search State of Knowledge Report on Rubber Modified Asphalt, if you just Google that term, you'll be able to find it. So you might want to take a screenshot now or just jot that down. But this is put out in 2021 by Butler and Rath. Now, pivoting away from GTR and looking at polymer modified asphalt binder, there have been a lot of LCCAs on polymer modified asphalt binder. The one that we're going to look at is an unmodified full structure versus a polymer modified surface versus a polymer modified surface and base, which is called a perpetual pavement in this study. Now, this again is very important because we're looking at not only changing materials, but also potentially changing design. So when we think about pavement structures and we look about modifiers in asphalt pavement, definitely spend time playing around with what does it do in the design process. You're not only changing the materials, but you could potentially be changing the design, and you can really leverage that, especially in a life cycle cost analysis. And so what they did is they looked at an LCCA versus all layers being unmodified. And they found when you just put a polymer modified surface, you save 6.5%. But then when you do that perpetual pavement, which is a polymer modified surface and base, your LCCA actually saves 15.5% versus an unmodified structure. And then they also did different combinations. This is a very nice report. I'm not going to get into all the details, but they also looked at other polymer modified combinations, and they kind of bounced around between that 5 to 15% of savings, depending on what structure, what part of the structure you modified and what type of modification you actually did. And so this was put out by Mark Buncher and Rosenberg in 2005. And again, if you search Understanding the True Economics of Using Polymer Modified Asphalt through Life Cycle Cost Analysis, this should pop up as a PDF, one of the top ones. And I encourage you, if there's some things here that piqued your interest, you can definitely leverage this report in order to get some more details. Now, the next life cycle assessment that I'm going to look at is just for the asphalt binder. And we're going to turn to the Asphalt Institute here. And the Asphalt Institute actually performed a life cycle assessment looking at neat asphalt binder, SBS modified asphalt binder, rubber modified asphalt binder, and polyphosphoric acid or PPA modified asphalt binder. And they just again looked at the terminal. So extracting the material out of the ground, transporting it to an asphalt binder facility, modifying it at that asphalt binder facility, putting it on a truck, and then that's when they stopped this LCA analysis. And I figured this wouldn't be a good presentation if I showed some data, and we might actually have a quiz here at the end as well if people are interested. But you can see here, this is a list of those 4 different products. So SBS modifications there at the top, PPA is number 2, ground tire rubber is number 3, and then no additives are number 1. And you can see this is just looking at the global warming potential over a 100-year period which is carbon dioxide equivalents. And you can see here that the SBS has the highest, PPA next, GTR, and then no additives. However, I encourage you to remember this is just looking at the terminal. This is just cradle to gate. We're not looking at the lifespan of the pavement. So if you combine this with that previous study that looked at SBS modified pavements, they actually saw expansions of life or reduced costs over the life cycle cost analysis. And I would hazard a guess that if you're seeing reduced costs, there's a very good chance you'll also see reduced emissions over the life of a pavement. So this is just a snapshot at the very beginning, but I think it shows the potential of how we could potentially move forward. Now, like Napa, the Asphalt Institute has this posted on their website. I find the easiest way to find it is to search life cycle assessment of asphalt binder. And this was put out in 2019, and it was a collaboration between Asphalt Institute and then a consulting company called ThinkStep. Now, kind of digging into some of the data behind here, because I do think it's important to kind of look at different variables associated with it. And don't worry about the color of these bars, worry about the x-axis, which is SBS contact, and then the percent change in impact from asphalt without an additive. So you can see the more SBS you add, the higher the impact there is. And you can see it goes anywhere from 0 to 140% increase in impact. So this is just for SBS modified, but if we look at PPA, SBS goes anywhere from 10 to 120% increase. PPA only goes from about 3 to 40%. And then continuing on, GTR only goes from about 5 to 20%. And those color lines that I kind of told you to disregard before, but they're just different sorts of emissions that they looked at. And they looked at the global warming potential over 100 years. They looked at global warming potential over 20 years. They looked at primary energy demand, acidification, eutrophication, smog, and water consumption. So these are the different either emissions, waste, or environmental impacts that the Asphalt Institute looked at when looking at these three different modifiers. And they went ahead and they looked at them at different levels to get an idea of how changing the level potentially impacts the Lcca. Now, transitioning to polyethylene, I found a very nice report looking at a life cycle assessment using polyethylene, and they compared conventional HMA, which is the control, to polymer modified HMA, and then polyethylene modified HMA. And you can see in the chart on the right, they have 4 different leathers of what they call recycled polyethylene at 4 different levels, 0.2, 0.4, 0.6, and 0.8. You can see they divided it into the material phase, the construction phase, the use phase, the maintenance and recovery, maintenance and rehabilitation phase, and then the end of life. So that's all put out real nicely. And this one graph that I'm showing here is the global warming carbon dioxide equivalents. And they looked at from a cradle to gate only. The polyethylene's overall impact fell somewhere between a conventional and a polymer modified impact. And they, again, looked at different ways you can try and extrapolate this out over the life of the pavement. And you can do that a couple different ways. You can either thin the structure, and they found you can thin it by up to 12.5% by using polyethylene, or you can extend your life before the next maintenance is required by 7%. So again, lots of levers that you can pull, lots of different ways that you can look at these different materials and how to quantify them. Now, I do apologize. This is a transportation research record. It's been published. However, if you search life cycle assessment of asphalt pavements with recycled post-consumer polyethylene, there is, and I misspelled polyethylene, I apologize, but there is actually a preprint of this available. So you can read all of their findings. There are kind of watermarks over all the findings. If you have access to TRR, you can get the clean version, but there is a preprint out there, which is essentially the same content, and you can find that by searching this phrase here below. Now, asphalt emulsions, I could talk all day about asphalt emulsions, but we're going to start with the life cycle cost analysis. And again, there's been several studies, dozens of treatments looked at, University of Nevada, Reno, Iowa State, Rowan, Texas State, Georgia Tech, NCAT, and the University of Arkansas. We've all done areas or analysis in this. You can see here, this is a project I did with a fantastic grad student of mine, Logan Kynell, and then harvesting data from a class project. We told him to put one treatment on RDOT's entire highway network over a 50-year lifespan, and this is the total cost. Disclaimer, I'd never recommend putting one treatment on an entire network, but it is a good example of comparing these different treatments on Arkansas's network using roadresource.org to generate it. So this was a lot of fun to do with the class. Now, if you go ahead and read all of these papers, which I'd be very happy to talk about at a conference, perhaps over an evening discussion or something, but all of these studies have very similar conclusions, whether they're theoretical or they're using field. Time and time again, if you have proper preservation, proper maintenance, it is cheaper than rehabilitation and reconstruction over the life of a pavement. Simpler treatments, meaning just asphalt or asphalt emulsion, no aggregates, they tend to have a lower life cost than the more complicated ones. When you add aggregate, when you move into the hot mix treatments, that increases the cost. But a really big takeaway too is blending these treatments can really optimize a system. And actually, Sadie Casillas and I, she was another phenomenal graduate student of mine, we used another class and we actually looked at combining treatments and we had a second paper. But the point is that blending treatments can really optimize your system. Now, the life cycle cost analysis of asphalt emulsions is quite defined and developed. The life cycle assessment is not quite as developed. And this is something that the Pavement Preservation and Recycling Alliance, or PPRA, is actually very interested in moving forward. And we are looking long-term to develop EPDs, or environmental product declarations, for treatments, but first we're focusing just on asphalt emulsions. So we're developing a life cycle assessment, we're writing a product category rule, and then we're going to develop 8 environmental product declarations. And the 8 environmental product declarations are going to look at neat and polymer modified, with and without rejuvenators, and with and without fuel oil. So if you look at all the different combinations there, you have 8 different combinations toggling those from neat or polymer, with and without, those type of things. We have 8 different total asphalt emulsions that we're making EPDs for. And once we get those EPDs for the actual asphalt emulsion, hopefully we'll be able to then incorporate those with aggregate EPDs, and then we can start looking at treatments, not just the asphalt emulsion. And our anticipated rollout date for the 8 EPDs is December of 2022. So I encourage you to keep an eye on any sort of communication from PPRA, EMA, ERA, ISSA, or AMAP, because hopefully we'll be able to have some conversations about those 8 EPDs first thing next year. Now, finally, the last example I'm going to look at, I know this is a 1-hour webinar. I know we're at 52 minutes. I appreciate everyone's patience for hanging in there. And I do see that there's a couple of questions, and we'll get to those in just a second. But let's take a look at rejuvenators. And I really like this study. This is very interesting because they kind of combined a life cycle cost analysis and Lcca. And what they did is they explored rejuvenating agents on porous asphalt. They did both a lab and a field study. The nice thing is that they actually looked at the performance in the field. So they looked at deceleration rate and skid resistance. They combined all these different factors from both the lab and the field. But what was very interesting is they quantified the damage to society by the environmental inputs by developing what they say is a shadow cost. So when I've been talking about the environmental pillar, I've been talking about emissions, I've been talking about wastes, all those type of things. What they did is they took those environmental impacts and they actually translated them to a dollar amount. So what they did is they took their Lca and actually kind of translated that into an Lcca. And this is very nice because it allows you then to just present dollar amounts. Now, this was a study done over in Europe, so the units are in euros, but they call this a shadow cost. And this is a very interesting concept. I had actually never seen this paper before. And this is one of the reasons I really like doing these webinars, is I always try and comb literature to see if there's things that I missed, to explore different areas. But this concept of shadow cost is interesting because it changed the human toxicity, the climate change, the eutrophication, acidification. It changed all those environmental impacts into a dollar amount, or in this case, a euro amount. So something that I thought was very interesting, and there are other studies out there. There are actually quite a few from industry. I tried to shy away from that just because sometimes some industry study have relatively specific agendas, and I don't feel comfortable saying whether or not that's happening or not. So I tried to focus mostly on academic reports in this summary. So as a presentation recap, sustainability in my mind means you're looking at economic, environmental, and social pillar. The life cycle cost analysis is the cost over time, and your LCA, your life cycle assessment, is your emissions and waste over time. EPDs, they're coming, and I see them as an SDS from the environment because many agencies are moving toward either incorporating or requiring EPDs. And there really is significant literature available for modifiers in both the area of life cycle cost analysis and life cycle assessment. So I hope that you have the opportunity to explore some of those if you are interested. So with that, thank you very much. I see a couple of questions in the chat box, and if you give me just a minute to read those and reflect on them a little, if you have any additional questions, please feel free to toss them into the question box, and I'll just start going through them. I understand if it gets to the 1 hour mark and you gotta bail out, that's perfectly understandable, but I really, really appreciate you joining us today. So the first question is, can you credibly compare cradle to grave LCAs or EPDs across competing technologies such as different types of flexible pavements, hot mix asphalt, warm mix asphalt, cold in place recycling, and rigid pavement? Confused, thank you. So that is a phenomenal question. And I wanna make sure I don't misanswer this, but it's my understanding that your EPD is based on a specific LCA and a PCR. If you do an LCA and a PCR that includes all of these different technologies, then yes, you can compare the EPDs next to each other. But if you have the, I don't know if I can say this, but the Portland Cement Association doing an LCA in a silo and they generate EPDs, and then you have the Asphalt Institute doing LCA on asphalt binder and a PCR and generating EPDs. You cannot directly compare those two because they're based on different PCRs and they're based on different LCAs. And I've talked with a lot of people in the industry, and a lot of people think that it may be a mistake for these silos to be forming because you can't compare them. And if we really wanted to do proper EPDs of roadway technologies, our LCAs and PCRs should be on roads in general, not specific types of roads, not specific technologies, but just roads in general. Now that's a huge project, and it would require collaboration across multiple industries, so you can imagine how that could sort itself out. But it's my impression that unless the LCAs and the PCRs are developed all together, you cannot compare two different EPDs. So thank you for the question. It's a great question, and that is my understanding of that topic. The second question, oh, this is an easy one. Can we get a copy of these slides? Yes, it's my understanding that if you're signed up for this webinar, you will get a link to the recording. And I guess when you say copy of slides, I'll let Allie take that question when she's signing off. I would be happy, you can send me an email. I'd be happy to send you a PDF of these slides. I got no problem with that. So my email address is right there. So just shoot me an email. I'd be happy to do that. The next question is, anyone doing any work with biochar added to binder or aggregates? And I am actually not 100% sure. During my literature review, I did not see anything about biochar, but that does not mean it's there. So there's a couple things. First of all, if you want to send me an email with any specific combination, I'd be happy to do a quick review on it. You know, just a couple minutes. I'm not going to do a full job, but I'd be happy to do a quick review. Another thing is I encourage you to go to TRID database, TRID database. So if you Google TRID transportation, it takes you to a search engine that's explicitly for transportation articles. So if you go to TRID and you search biochar and binder or biochar and aggregates, if you search different combinations of those phrases, there's a very good chance that something will pop up in any area you're looking at. So you can either shoot me an email, I'd be happy to kind of get the ball rolling, or in the area of modified asphalt products, I would go to TRID, T-R-I-D. It's much less confusing than just using Google because they're all transportation related and they're all pre-sorted. They're either state reports or published reports. Oh, Scott Demetro, he said, did anyone else lose sound? I can't say anything about that, but as Ali mentioned, it has been recorded, so you can listen to my melodious voice whenever you choose. Now, there was a request for asking about specific products. I think I kind of covered that already. I would recommend going to TRID, typing in your specific search terms. I'm actually not willing to take specific conversational questions at the end of this webinar, just because logistically, I'm not sure how that would work with the recording, but shoot me an email and I'd be happy to continue the conversation. Oh, so those are all the questions. I had a couple of saying nice presentations. Thank you. I appreciate that. I enjoyed it as well. But if there are no more questions, oh, here we go. We got another question. Okay, at the end, in terms of GHG, which is a greenhouse gas emission, isn't CO2 equivalent per kilogram mile per year the metrics that really matter? So that's actually a great question. So we're talking about these emissions. You can do a lot with units, and you have to be very, very careful with how you present the units. Now, in my mind, you want to be as specific as possible with the units over whatever time frame you're doing. So if you're only doing cradle to gate, actually like a short ton measurement is a good measurement because you're just measuring the amount of material you're producing. But if you're doing a cradle to grave, it might actually be better to do some sort of per lane mile analysis, because then you're actually going out in the field and you're placing different thicknesses, different amounts of these material in the field. So I would say that actually it depends on the unit you want to use, depends on what sort of analysis you're doing. So I agree that kilogram per lane mile per year is probably best for a cradle to grave or cradle to cradle. But if you're just looking at cradle to gate, I would stick with kilograms per like short ton or whatnot.
Well,
All
thank you.
right. Well, okay. Yeah, I think that's it. So I'm going to turn it back over to Ali. But thank you all very much for joining me. I appreciate it.
Thanks again, Andrew. Really appreciate you taking time out of your day to present. As Andrew kind of mentioned, we can provide the slides, a PDF version. We'll include them in the email when we email out the recording of the presentation. With that being said, thank you guys again. Thanks again, Andrew, and we look forward to our next webinar coming up in a couple of months, likely. Thanks again.